Good afternoon. It's time for us to talk a little bit of OpenStack and Kubernetes. So considering the time of the day, how far many of you have traveled, and how tired you might be, and how many other sessions there are, I think we have a pretty good quorum for the presentation. So thank you all for being here. So what we're going to talk about in the next 30 minutes, also, I landed today, so you cannot hold me responsible for any stupid thing that I'll say in the next 30 minutes. Because that might happen. So we're going to talk a little bit about OpenStack and Kubernetes, why you would deploy OpenStack and Kubernetes, why that's something that sounds interesting and that you should probably be looking into, and what tools there are. I'm not going to spend as much time on the tools as I was hoping to do, but we're definitely going to cover some of the areas around this whole idea of deploying OpenStack and Kubernetes. That is me, a long time ago. Let me take the cursor out of my face. There you go. Feel free to interrupt me anytime if you have any questions. I'll happily answer during the talk. Again, thank you all for being here. I work at Red Hat, still work there. It's actually a great company to work for. If you want to work for Red Hat, let me know. And I've been at OpenStack for probably 5 years already. I'm part of the technical committee. And I do quite a few things on the community. On the technical side, I've done several things in OpenStack, but right now, lately, I've been focusing more on deployment tools. And as you'll figure out throughout my talk, I've been working a lot on TripleO. So if any of my comments sound biased, it is because they are. So I'm going to be completely honest with you. That is my Twitter handler. If you have any feedback on the talk or anything that you want to ask me, you feel free to follow me. Someone has to feed my ego, and that's you. And that's my email address if you have any other comments that you want to share. So let's start on the why you would deploy to OpenStack Kubernetes, why this is something that sounds interesting. And based on the research we've done, and not only the TripleO team, really, but the entire OpenStack community. This is something that we've learned not only by doing our own experiments, but also by looking at what other projects have done so far in the last few years or several years. These are some of the examples of why you would want to look into this. One of the reasons is having service isolation, and this really applies to not only deploying OpenStack on Kubernetes, but also applies to deploying OpenStack and containers, like containerizing OpenStack in general. One thing that you get when you do that is isolating the services, the OpenStack services that you're going to deploy. So you get this little unit of computation, if you want to call it that way, that has the OpenStack service in it and nothing else. So you get the OpenStack service, its dependencies, and nothing else. So you isolate it from the rest of the stack and the rest of the things that you have running on your machine. And that is great, because one thing that we probably all know, if you've run OpenStack or if you contributed to OpenStack, one thing that actually happens in OpenStack is that we share a lot of dependencies across the entire stack. So sometimes upgrading OpenStack, and when you share, sometimes actually upgrading software when you share so many dependencies might be hard, especially if you're dependent on distro packages and all that. So you end up having to upgrade everything at once or nothing in some scenarios. So this provides some extra level of isolation for each of the services, which is something good, I believe. You get ease of upgrades, and I'm not trying, I'm not trying to say that as soon as you install Kubernetes in your cloud and everything is going to work magically well and there will be unicorns everywhere. When I say it's going to provide some ease of upgrades, is because it provides some processes, some extra logic that you can rely on. Now, there's a lot that you got to do to get it right. There's a lot you got to study, analyze, and code, and put in place for these ease of upgrades to actually work well for you. But the things that you got logic, you got some processes and some extra features in your stack that are provided by this orchestrator tool that you have installed, which in this case is Kubernetes, that you can rely on. And it provides some deployment flexibility because you don't depend on a static architecture that is entirely thought out beforehand, but you can rely on the orchestrator deploying some of the services for you, and the scheduler in this orchestrator to decide where those services should run or shouldn't run. So you have this flexibility where you can tell the COE that you're relying on, in this case Kubernetes, to please deploy some of the services and for it to decide where those services should run. Of course, that you gotta have a set of nodes. It's not gonna be a crazy circus where you just like throw containers in it and then it's all gonna be mixed and you don't know what's actually happening. You gotta know what's happening in your infrastructure, and you gotta have some order in there. But within this order that you have, within this architecture and this cluster, kind of like classified architecture, you have some extra flexibility when you decide or you let your COE run those containers in different nodes and things. And you have an ease of scalability because, again, you have this orchestrator that holds, at this point, holds some of the logic of your architecture, so you can just tell it to please keep scaling it as you need on demand, or not really on demand. Whenever you tell it, you can ask the COE to just scale your architecture. It can scale it out or in, and really depending on your needs and what you want to do with it. But it does make it easier for you to do it. You have the logic once, and you don't need to keep adding more nodes, so you can actually run some services that you can run two instances of the same service in the same node, and that's probably fine when you have this kind of architecture. And like I said before, like you have reusable containers in the orchestrator. Like you don't have to redeploy things several times. You have the logic. Like now, your orchestrator holds some of the logic of your architecture, and you can reuse that. You can just instruct it to dynamically do things for you as you need. And you can reduce the resources footprint. So this is not going to magically make your software, or OpenStack in this case, leaner and faster to run. So containers are not necessarily going to bring you faster deployments or faster software or processes. That is actually a myth. They're not necessarily faster than VMs, but they are gonna the resources footprint across your entire architecture is actually going to be reduced depending on, of course, on how you decide to run these containers or not. So you're not going to have always like 3 controller nodes running. If you don't want to, you can have 2 and just ask the COE to add an extra node whenever you need it. And it's going to be cheaper to some extent to do that. So again, Kubernetes or COEs are not going to magically do everything for you. They're not going to fix all your problems, but they do bring some features that are very interesting, especially when you got to run and maintain such a complex architecture like OpenStack. But if you look at OpenStack from a very, very high level point of view, it is actually just apps. Like to most of the case, like it's basically just apps. Right? You have more complex apps doing more like critical or sensible things, like managing your data or running VMs for you. But if you look at the API nodes, the scheduler and things like that, they're just services that are running, and you can. Or something that I would like to see happening more often is like we treat OpenStack as more like a cloud-native kind of application, and not necessarily as this massive static cluster that you got to run in your infrastructure, and that once you deploy that, you cannot touch it anymore. Actually, I would like to see it being more flexible, and this is something that is happening more and more in the community, where we're becoming more aware about OpenStack being more like a cloud-native app, if you will, for whatever definition of cloud-native. But something like linear and thinner that you can run in a more flexible way. Now, what do you want to containerize if you ever decide to move into containers, or if you ever decide to run your OpenStack deployment on Kubernetes? I like to classify in 3 different groups. The first one is you can containerize some of the OpenStack services. You don't containerize the entire thing. You don't containerize your entire cluster. You containerize some of the OpenStack services, like, for instance, the API services, the ones that look more and more like cloud-native apps. You get the Nova API, Glance API, and the API services. You put them in containers, and you run them in Kubernetes. Because those are the ones that, if they die, it's not, I mean, Nova API dying is probably not as critical as Nova Compute dying. I guess. So it's easier to just say, like, well, I had 3 instances of Nova API running. One of them dies. I can always take another one up and ask the COE to run it in a very flexible way. So you just, like, for instance, you just containerize your control plane. You don't necessarily have to containerize your data plane or your, like, compute nodes and volume nodes. And of course, if you do this, you probably want to also live outside of containers, the third-party services that you depend on, like RabbitMQ and MySQL. Because you already have those running in your bare metal nodes, you're probably using those for other things, and you have, let's say that you have it figured out, like you have MariaDB or whatever database you're using running on bare metal or VMs, and you just don't want to move the data. Another option is to containerize just OpenStack services. So you get all the OpenStack services and you containerize them, from Nova Compute to Nova API, Nova Scheduler, Glance API, all the OpenStack services, everything that is provided by the OpenStack community, you go ahead and you just put it in containers. And one of the benefits behind this is that you get more consistent deployments, and you know that all your OpenStack services are running in containers. So whenever you reason about your OpenStack services, you say, OK, it is an OpenStack service. I know it is running in a container, so it's likely running inside this COE that I have deployed, and that is managing all my services. So this is good for you if you're running an OpenStack yourself. You want to have some extra consistency in your deployment. And by deploying just like containerizing just the OpenStack services, you live outside the third-party services like MySQL and RabbitMQ. Again, same reasons. You have your data in MySQL and you don't want to move it. You have figured out how to run RabbitMQ. You don't need extra nodes. You don't need any flexibility on the side. You have the HA that you need already, so no need to move those. The third option is to containerize everything. You get your third-party services, and you get all the OpenStack services, and you go ahead and you put your entire OpenStack cluster inside containers, and in this case, inside Kubernetes. Now, just like in the previous case, what this brings is extra consistency in your deployment. You know that everything that has to do with your OpenStack deployment is running in containers, and it's running inside Kubernetes. Now, you don't have to. If you move MySQL, if you move RabbitMQ inside containers and you decide to run them in Kubernetes, you don't necessarily need to change the way you're running them. You don't necessarily, if you don't want to treat those as a, cloud native apps, which they're not, they're actually stateful apps. If you don't want to have that extra flexibility when you deploy MySQL or RabbitMQ, it's fine. You can teach your COE to not treat them that way, and you can just have them pinned to specific nodes and have the data in specific nodes and just control it the same way that you were doing as if you were on bare metal. And again, the only benefit of doing this is having extra consistency in your deployment, which is something you want. You want to have a single way to reason about your deployments. You don't want to have 10 different ways to reason about your deployment. Like you have some applications running in Kubernetes, some applications running on bare metal, some applications running somewhere else. You gotta have a single way to reason about it because it's just easier and it's consistent, and consistency is good. Not only when developing, but also when you're doing ops. Now, getting a little bit into the tools, what tools there are that you can use today to deploy OpenStack on Kubernetes. I'm gonna cover just 3 of them, and I'm not gonna go in deep dive into any of them. I'm pretty sure there might be other tools outside the OpenStack community. The reason I picked these 3 tools here is because they're part of the OpenStack community, and they're known quite well. So the first one is openstack-helm. They're actually applying now to join the OpenStack community, the big tent. So openstack-helm is a set of Helm charts to deploy OpenStack on Kubernetes. It relies on Helm. And for those of you that don't know what Helm is kind of like a package manager for Kubernetes. So you get this service called Tiller running inside Kubernetes, and then you can just instruct it as you would do with yum or DNF or apt-get, and you can go and tell it, hey, please install this package or upgrade this package or delete or remove this package here. So openstack-helm is a set of charts. Charts is the name of the package for deploying OpenStack on Kubernetes. So they've developed charts for every service in OpenStack, including the third-party services, MariaDB, RabbitMQ, and everything that you need to run OpenStack. So basically, you can go and tell Helm to please install OpenStack Okata for you, or OpenStack Queens for you. Well, not really Queens, Pike for you, and they'll go and do that. If you saw the keynotes this morning, that is what the AT&T team used to demo the OpenStack deployment that they have. And it's a neat solution. It relies specifically on tools that are provided by the CNCF community, which is good if you're completely tied to the community and you don't have any other constraints. There's kolla-kubernetes. So there's more to Kolla than just kolla-kubernetes. The reason I'm only mentioning kolla-kubernetes is because it is a part of Kolla that takes care of deploying services on OpenStack. Now, kolla-kubernetes is a set of Ansible roles to deploy OpenStack on Kubernetes. But in kolla-kubernetes, if you look deeper into it, you will notice that they call Helm in some parts. And it's not necessarily that they're using Helm to run these services, because they're not really consuming Helm charts. What they're doing is using the templates, the Jinja templates, and generating the Kubernetes templates out of those templates, calling the Helm CLI. So this is kind of confusing. But what they're really using from Helm is the CLI to generate the things that they're going to run inside Kubernetes. So the reason I'm mentioning this is because if you use kolla-kubernetes, you don't really depend on another service running on Kubernetes to manage the deployment for you. So if you're using openstack-helm, you kind of depend on Tiller running because it is using Helm entirely. In the case of kolla-kubernetes, you're just generating templates, and those are the ones that you end up running on Kubernetes. And the third option is the one that I'm spending most of my time on lately, and it is TripleO. It is actually a work in progress. So the Pike release has support for deploying OpenStack on containers, and it uses Docker for that. You can get a full OpenStack cluster running on Docker. Now, the next step that we're taking is moving all these containers into Kubernetes. So this is the part of the work that is in work in progress. And the way we're doing that is by creating specific Ansible roles for each of the services. And unlike in the kolla-kubernetes case, or even the OpenStack-Helm case, we're not really depending on Helm at all. What we're doing is talking to the Kubernetes API directly so that we don't have any extra dependency or any other templating language inside our stack. So with these roles, what these roles actually do, they talk directly to the Kubernetes API, and they create the resources that there need to be, that there should exist in the Kubernetes API to run the OpenStack services. So something neat about these roles is that you can, when they'll be complete, you'll be able to use them independently from the entire stack, or use them directly with TripleO if you want to have an entire life cycle, which is something that TripleO is very good at. So stay tuned. Keep an eye on all these new repos that we're going to be creating in the next couple of months with all the roles that we've been working on. Now, some heads up for Kubernetes in case you're thinking about moving there. Probably one of the obvious ones is that it is another system you have to maintain. And as I said before, installing Kubernetes is not going to solve all your problems. It's probably going to make some of the problems easier to solve, but it's also going to create new problems that you got to deal with. Now, you got to kind of like evaluate whether all these things that Kubernetes is buying you are actually worth the effort of deploying it and maintaining it. Because it is another system that you got to maintain. It's another distributed system. It's another complex system. It's another system that you got to provide HA for, and that you got to make sure that runs. Because it is now not going to run in your system. It is also going to run your OpenStack cluster. And if Kubernetes goes down, your OpenStack cluster is going to go down as well. And you don't want that to happen. So something to keep in mind is that if you ever decide to go down this road, you got to know Kubernetes very well. You got to know what it means to run Kubernetes. And you got to understand that this is another system that you're going to be running in your cluster, and you got to maintain it running. One problem that we actually faced, and we're still kind of like dealing with it a little bit on the TripleO side, is that out of the box, Kubernetes provides flat networks, and it expects a flat network. Now, there are plenty of plugins to create more complex networks there. I'm not arguing whether Kubernetes can or cannot do more complex networks. I'm saying that out of the box, this is what it provides, and to provide more complex networks, you probably need to write some plugins for it. So it's not as straightforward as talking to Neutron, I guess, and creating new VLANs and just consuming those, and telling your different services to consume those VLANs. The way Kubernetes likes to reason about its networking layer is by just having a flat network to some extent, unless you have other plugins like Calico, Flannel, or whatever you want to put in there. IPv6 actually landed recently, and there was some support for the kubelet side of things, and the part of the IPv6 support that landed recently is the support for the API services. So that means that now if you deploy a service on Kubernetes and you want to use IPv6, you should be able to do that now. I haven't tested it myself, but by looking at the pull requests and the progress on this area, that seems to be the case. This is, of course, critical or really bad if you depend on IPv6, which is one of the features that TripleO has, and not having support for IPv6 would mean breaking backwards compatibility in TripleO, which is something that we definitely don't want to do. So this is good news. Still has to be tested thoroughly, but at least it looks like things are moving forward on this side. So definitely look into this if you depend on some of these features, or even complex networks, like I mentioned before. So some HA features are missing, and I know this sounds like a very generic rant here, but what I'm hinting on here is that there's no, trying to find the right words to say it, there's no proper fencing for pods or kubelet nodes in Kubernetes, and this is something that we're also trying to cover and talking more with the Kubernetes community, trying to find a better solution for these things. So if some of the nodes goes down and you want to fence it completely from the cluster, there's not a very good way to do it. And again, this is a critical feature if you want to provide HA, full HA for your Kubernetes cluster. And since you, like I said before, since you have to maintain it running, and this is another thing that you have to provide HA for, and that is going to maintain and it's going to run your OpenStack cluster, you might be interested in this feature here. So Kubernetes is very good at providing HA for the applications it is running. And more resources are coming in to manage and reason about other applications, like stateful sets for reasoning about stateful applications like databases and message queues, or some of the message queues out there. But sometimes it is hard to provide proper HA for your Kubernetes cluster. And this is one of the features that is actually missing there that we're trying to solve to some extent. So look into this if you're thinking about running on Kubernetes, or if you're running Kubernetes and you didn't know this, you might want to look into this anyway. And this duplicated. Okay. So some advice. If you're thinking about moving into Kubernetes, first label your nodes. This is something that we did a lot on, or it was embedded on TripleO when we were deploying things on bare metal. And each of our nodes has a label. We have the controller nodes, we have the compute nodes, storage nodes, and all that. You probably want to keep doing this because and it's probably because of this advice that's coming up next, but by labeling your nodes, you can classify your deployment, and you know what each of the nodes is doing or are doing, and you can have different groups, and you can reason about your deployment in different ways. And one of the reasons you also want to label your nodes is because by labeling your nodes, you're also going to be able to place the containers if you have to. And sometimes it's good to place some of the containers, like if you're running if you're running Nova Compute inside Kubernetes, if you're running a volume service inside Kubernetes and stuff like that, those are services that you have specific nodes where you want to run them, right? And there are different ways that you can do this in Kubernetes. But one of them is by telling Kubernetes to please run those services in this specific group of nodes. And you probably want to do that because you probably don't want your Nova Compute running some other service. You might be able to do that, but it might be better for your architecture and your deployment to have Nova Compute running in the same node where your virtual machines are. So if you ever need to place your nodes, you might want to have labels for those nodes so that you can tell Kubernetes where those services should run. But placing nodes might become very sexy and common and addictive. And if you start overdoing your node placement and your container placement, you're not going to be leveraging that flexibility that Kubernetes is supposed to be providing to you and to your deployment. So be sure that you use node placement sometimes, but not always, so that you'll allow Kubernetes to use its scheduler and you will leverage all the features that you are supposed to be getting out of Kubernetes as far as deployment flexibility goes. Config maps and secrets. This is something that we started looking into as soon as we started migrating from normal containers or even bare metal into containerized deployments or Kubernetes-based deployments. If you know OpenStack and the OpenStack deployments, you know that we rely a lot on files for the config options, and we wanted to have a way to not only store the secrets but also store in a kind of like distributed fashion some of the configuration files that we have. And it's not because we want to have a centralized place to put them all. That is probably, I mean, to some extent that is good, but not always. But it also allows to making the config file generation easier and more distributed. So right now, in the Pike release of TripleO, we still generate the config files using Puppet, and these config files are written on the file system. And they're written on the node where the config files are generated, which is limiting. It's good for the solution released in the Pike release, but it's very limiting if you're willing to deploy your containers in a distributed fashion or in a more flexible way and leverage Kubernetes for that. So one thing that we can do with this is we can generate the config files and put the content on the config map and have the different containers consuming those. Now, it's not a magic solution. If there can be versions mismatch if you're not careful. And if you end up using the same config map always for the service and the same name without kind of like tagging the version or something, you might have some conflicts if you're trying to upgrade. So you got to be really careful on this with these kind of things, especially when you're centralizing, and especially when you're messing with your configuration files. Like you don't want to mess with your configuration file and then end up restarting the container and then breaking your entire cloud because you forgot to set up variable or something, which can happen also with file system-based configuration files. But it's probably easier to mess up all your cluster if you have them centralized somewhere. Have dedicated namespaces for your OpenStack cluster. And so if you're familiar a little bit with Kubernetes, you know that you can have different namespaces in Kubernetes. And namespaces in Kubernetes are kind of like tenants for us in OpenStack. Probably don't have the same properties and characteristics, but it's kind of like provides a good idea of what they are. So use a different namespace for your OpenStack deployment. Don't have it messed up with or mixed up with the rest of your applications. One other benefit of using Kubernetes is that you don't have to only use it for deploying OpenStack. You can also use a single Kubernetes cluster to run your OpenStack cluster and also run some other applications if you want. Of course, if you share the Kubernetes cluster between your OpenStack cluster and some other applications, you're also sharing resources. So you got to account for all that, but it's something that you can do. And yeah, turns out that's all I have. So if you guys have any questions or any other comments, by all means, do them now or catch me up later. All right. Thank you. I don't see any hands. Oh, there's one hand.
You mentioned that you're bypassing Helm by using Ansible to construct the Kubernetes API directly.
Yes.
And is that a deliberate choice? Is that part of your architecture that you've documented?
It is a deliberate choice. And there are a few reasons behind that. One, sorry, you're right. So the question is, we're bypassing Helm, and we're deploying OpenStack services by talking directly to Kubernetes. The question is, why are we doing that? Is that a deliberate decision, and what motivated that? Right? Okay. Yes. So we did an analysis when we started working on these Ansible roles for TripleO, and there are a few reasons behind it. One of the reasons is very specific to TripleO, and it is that in TripleO, there are several templating languages already. And adding Helm to the picture would have meant adding yet another templating language, which is Go template. And we didn't want to do that. We didn't want to have yet another templating language that consumers of TripleO would have had to learn. Also, having that other templating language would have meant adding another step in the entire process to also render those templates. And one thing we're trying to do in parallel, which is probably kind of like the story of why we also went down this road, is getting rid of many things that there are in TripleO, kind of like chopping the snowball off, and reduce some of the complexity we have, and trying to reduce the set of technologies that we have in the tool belt, I guess. So Ansible was already in the picture. And so one of the things was, well, we already have Ansible in the picture. We know already that we want to go down the Ansible road in TripleO. So why don't we just try to stay closer to the Ansible side of things rather than adding more stuff in it? And it turns out that they're not very old, but turns out that now there are the Ansible Kubernetes models that we could use, and we tested those, and they're fairly updated and stable, so we can just talk to the Kubernetes API and be very, very close to the Ansible way of doing things, where you just use models to talk to and do all your operations instead of running CLI commands. Does that answer your question?
Does that include upgrades?
Yeah, so the next question is whether this decision or solution includes upgrades. The answer is yes. Was that?
Doesn't this make it not TripleO?
It is still TripleO because you have an undercloud deploying an overcloud. It's just that you now have Kubernetes in the middle. But it's still a cloud on top of another cloud. So yeah, it's still TripleO.
Okay, so then you have an undercloud, right? Then as a part of the deployment, you deploy the cluster, Kubernetes cluster, and then on top you deploy the OpenStack.
Yes. So the Kubernetes cluster is running. So the question is, so you have an undercloud, and then on top of that undercloud, you deploy a Kubernetes cluster, and then on top of that cluster, you deploy an overcloud. Yes, the answer is yes. The Kubernetes cluster is running on the bare metal nodes that the overcloud was running on before. Now, the overcloud is still running on those nodes. The difference is that it is running inside Kubernetes. Any other question? There's one.
How do you deploy Kubernetes in the undercloud?
In the undercloud or the overcloud? All right, so I guess the question is, how do we deploy Kubernetes on the overcloud? We are using TripleO to deploy Kubernetes, and to be more specific, we're using kubespray, which is already part of the CNCF community. Well, it's an incubated project of the CNCF community. It's a set of Ansible roles and playbooks to deploy Kubernetes, a Kubernetes cluster. So we're using kubespray to deploy Kubernetes.
So you are not using Heat or
So Heat is calling the kubespray playbooks, and kubespray is deploying Kubernetes on top of those bare metal nodes. What's that? Sorry, I didn't get your. Oh, Magnum. So whether Magnum is part of it? No, Magnum is not part of the picture, no.
Yeah, when you deploy the Kubernetes cluster, I'm not familiar with the project that you mentioned,
KubeSpray, yeah.
KubeSpray, does it support like a HA type of deployment, like multi-master, multi-etcd, or that kind of thing?
So the question is whether KubeSpray supports multi-master and multi-etcd and like some sort of like HA deployment, and the answer is yes. I think there's a lot to improve in that area on the HA side of KubeSpray, but the answer is yes, it does support it.
There's a KubeSpray session on Wednesday afternoon.
There's a KubeSpray session on Wednesday afternoon. What's the time? 3:10. So if you guys have any feedback, definitely join us there. Because now that I know, I'll be there. Awesome. Any other question? Oh, one more over there. I'm sorry.
So when you're deploying OpenStack within Kubernetes, how are they sharing resource usage information between each other? For example, if I'm launching a VM inside of OpenStack and it's using X number of resources, and then Kubernetes is already running containers that are running OpenStack components that are using so many resources, are the two talking to each other at all?
No. Not right now, no. Whether they should? So the question is, sorry, let me repeat it on the mic side. Is whether, now that we have a Kubernetes deployment and an OpenStack deployment, whether like OpenStack running inside Kubernetes, whether these two clusters are communicating on the resources that they are sharing. So if we're running a virtual machine and then there's Kubernetes running on some other containers, whether there's some synchronization between these two clusters and in the resources they're sharing and trying to be smart about it. So the answer is no. Whether they should or not, they probably should. But right now, the solution that we're working on doesn't have that. We might have it in the future, probably.
And I guess a follow-on is OpenStack's resource availability just pulling the raw bare metal information that it's getting from the containers or Kubernetes?
So the question is whether the OpenStack resource availability is pulling the resources straight from the bare metal, and the answer is yes. Which is one of the reasons you want to have these kind of like things isolated. Like you don't want your compute node running everywhere, and you want to pin it to a specific node, and you want to place it, and you want to make sure that you know where it's running, which is different for the API nodes. You're welcome. I see two hands. Question is what containers we're using. We're using Kolla images. Yeah, I think that's a straight answer. We're just using Kolla images. I guess like the reason I stopped for a second is because we're not using vanilla Kolla images. We're injecting some packages that we need as part of TripleO, for instance, like Puppet to generate config files. But the logic, like we even use Kolla build to build the images.
So once after we install the OpenStack with Kubernetes using the TripleO, at that time the user can use these Kubernetes as the usual container platform?
So the question is the user using TripleO after TripleO has deployed OpenStack on Kubernetes? I guess there are two answers to that. The first one is no, like you can talk to Kubernetes directly if you want to and just manage your services talking to Kubernetes. However, if you want TripleO to manage the lifecycle of your OpenStack cluster, then yes, you gotta talk to Kubernetes, you gotta talk to TripleO and let TripleO manage the lifecycle for you. So when I say lifecycle, I mean the upgrade of your services, when to upgrade them, what services to upgrade and all that. In the TripleO case, you have an undercloud and an overcloud, and you have a complete stack of applications managing the lifecycle of the OpenStack cluster for you. It's true that it's running on Kubernetes and that you could probably just manage it yourself if you know what you're doing and you want to do it yourself. But once you've deployed OpenStack with TripleO, I guess I would recommend just sticking with TripleO for the tool to manage the lifecycle of that OpenStack cluster. Yeah.
So I mean that after the install the OpenStack on Kubernetes using the TripleO, at that time, can we add some container apps using the Helm to inject in?
So the question is, after TripleO has installed and deployed OpenStack on that Kubernetes cluster, can we use a Kubernetes cluster to run some other apps ourselves? Yes, the answer is yes. Of course, if you run other apps on that cluster, you'll be sharing the resources that the OpenStack cluster is using. But if you know what you're doing and you know how many resources you have, then the answer is yes, you can totally do that. You're very welcome. I don't know how much time we have, but I can do this all day. So, any other question? I don't see hands. So, thanks again for being here and for all the questions. Have a great evening.